So welcome everybody in the webinar today for MotionCode, and today a little bit with a more practical orientation in how to program smart motors. Some short side notes at the beginning. This webinar will also be recorded and later on published in YouTube. So just for you as information that you know about. And another side note, if you have any question, feel free to place them in the chat so we can ask them during the webinar session or at least at the end of the session. So I'm happy to welcome every one of you in this webinar. I think it's an add-on webinar next to the one on Tuesday, where we had a more or less overview what MotionCode is. Today, we will go a little bit more deeper and also have some practical demos inside, how MotionCode works. Nevertheless, the first part will be a little bit theoretical from my side, which shows you a little bit an update what the MotionCode is and how it can be used for those who wasn't there on Tuesday. Short at the beginning, who we are, who is presenting today. It's Alexander Haberstro on one side as an application and service engineer. I think you can see his video already in the chat or in the Teams meeting. He will, as the MotionCode expert, will do the practical sessions, and me, as more or less the theoretical guy, will just give an overview where MotionCode will go and what's the idea behind. And so I think based on this short introduction, we can start in this webinar. So the some of you who was there on Tuesday, they know this slide already. So no worry, just 2 or 3 slides which are repeating, and then we go to the practical training. But to have a round package, we will start with this slide as well already today. So why MotionCode is a useful solution, or how can you use MotionCode? So we see it as tool to realize service-oriented architectures also in automation system. Therefore, also for decentralized software design, so going away from having everything in a central computer, instead having everything in intelligent devices, have the code already spread over these devices. And as a combination of both, it gives you the chance to realize a modular software design, which allows you to change pieces or combine different functional pieces more easy to realize a higher variety of your products. And why we believe this is important, or why we go this way with this surface-oriented structure, this decentralized structure. I think if you have a wider look and see how Amazon Web Services works with the doctrine of Jeff Bezos, who says that everything has to be service-oriented. So that's the basis of their success, I would say. And from this direction, it comes more and more of all areas of software development and so on, also in the automation sector. And that's the reason why we believe in that and why we follow this way as well. But we don't have to think all the time in big machines and big codes. We also can use MotionCode as a nice functionality to extend the functionality of a smart motor, adding some analyzers to the motion itself. So motion is still controlled by a PLC, by over bus systems, but I want to have some diagnostics like counting events, counting operation hours, tracking temperature, or what else, done directly on the motor. Therefore, MotionCode is a quite easy tool to realize this. And as well, it's easy programmable in C. C, I think the knowledge, everyone is in a closed software study, learns C, so it's easy to start with. And I think that we want to demonstrate today how easy it is and how it works. Then just some words, what's needed to use MotionCode. Of course, you need a D-Move or D-Pro series motor from us because they are able to perform MotionCode. You need a little bit of knowledge of BG parameters but there we will show later with the knowledge base how easy it is to get this knowledge. You need our IDE, which we show you today. You need a little bit of disk space, Java, Windows, and of course, as mentioned, you need a little understanding how to program in C. For who MotionCode is designed, or who can use or who can benefit from MotionCode. On the one hand, customers that want to realize an application. So if you have an idea what you want to program, you want to do it on our motors, you don't want to use a PLC, then don't worry. Even if you don't can program, we can do it for you. So you can buy the motion program as a service from us, so can just get the motor and the code as a package, and we do the work. But next to this as well, we address you who want to program by your own, who wants to be the master of your application and just want to get the platform to program our motors. That's also in the target, and there we will support you that you can start with programming and use our environment to realize your own decentralized solutions or your own motion codes on the motor. And then I already come to my last slide, beginning slide for today. So what is the actual package? What can we offer if you want to have MotionCode? Of course, our development environment that allows you to program all the libraries with the necessary motion commands to control and interact with the motors. An upgrader that gives you the possibility to download motion codes to the motor. Some sample programs to give you an idea how MotionCode works, how to perform with it, a detailed user manual and also a quick start guide to have a short and easy startup. And for the early adopters beneath you, we also offer 1 day of training for free to gives you a smooth and easy start with MotionCode. That is what is already available and what is ready to use. And based on this, what's the next of this 1 hour webinar? Of course, now it's demo time. So we will show you what's behind MotionCode and how it works. And therefore, we start with the IDE itself, the integrated development environment. You see it behind me. I think it's a common Eclipse compiler. Nothing really special in it. On the left side, you see a project explorer. On the right side, function libraries, a console in the bottom, and the program window in the middle. So everything is known for a programmer. And at this point, I will give to Alex for the first time, who gives you a live idea what's behind this IDE.
Hello together, also from my side. Just a few sentences about the MotionCode package. If you get our MotionCode, it's including the manual and also a zip file with the IDE. And the IDE, if you get the IDE package, we have the package, and there you get a zip file with the IDE. You get the manual and also some other stuff. The manual is quite useful and also available in English. It's both languages in once. And if you go to the IDE, you have to unzip it. I have it on my C file, and you get a ready to run Eclipse folder. You don't have to install it. You just have to install Java, and then you can double click on the Eclipse exe and already run it. I have it here with an empty project explorer. So the first step is to add a new project, and you have to use the project. Then you can here use a new MotionCode project. So it's no general C or something. It's a Dunker MotionCode project. Then you have to type in the name. And this IDE is already getting a full package of MotionCode. and everything you need is included here. Also some predefined functions and our predefined template. In the first step, I want to show you how easy it is to run the first code. We see here some errors. It's a little point we have to fix in the IDE. Sometimes this point here is wrong. Sometimes this path is away, but both is okay. So we choose the indexer. Here you can choose for which motor you are developing the motion code. We have dmove CO, dpro CO, dpro EtherCAT, and dpro Profinet. I have an VG95 dpro CO connected to the PC, and if I compile it here, we will see how easy it is to get the first motion code. As you see here, some scripts are running because it's not only a compiler, we also built the upgrader to download the motion code to the motor. And when you start the first time the IDE, you get asked where you want to have your workspace. I have it here. And in this workspace, the motion code folder is created, and you see it's the same folders like in the Project Explorer. And when we build or compile it, then we get this subfolder in the used version. And here we have a ready to run upgrader, which we can run. And this upgrader is used to download this motion code upgrade.bin file to the motor. So this is the compiled file, and everything else is just to download it to the motor. As we see here, I have connected an VG95 dpro CO, and now I can start the download. And because this will take a while, I give the word to Markus meanwhile.
Yeah, so thanks, Alex, for the first demo. So the ball is back to me, and I will give you a short point what comes next. You see what comes next is the upgrader. Alex is quite fast this time and has already showed the upgrader. You see it's close, the same look and feel than our Drive Assistant 5, which makes it easy to use the tooling to make the connection to the motor, interpret the data, because it has the same look and feel. There are no differences. So if you can use the Drive Assistant, the upgrader feels quite common for you. That makes it easy. As well, here we have the demo how the upgrader works. Alex has already showed it. Later on, will he give some information how it looks like with the motor. And then I think today comes the interesting part. We want to program in this webinar first motion code step by step in 4 steps to give you an idea how powerful motion code is and what is possible with it. This motion code should be able to perform a relative move at each positive edge on input 0. Then in the next steps, we will to modify the program in that way that it allows to modify the target speed and the position where the motor should go via CAN. Then we want to count the position cycles, so how often the motor do or performs this positioning. So we more or less count the edges. And at the last point, we want to store the value of this position cycle every second time. So with these 4 steps, we have the chance to give you a quite good idea what is possible with motion code. So the target is clear. We want to demonstrate the possibilities that you have with motion code, and as well want to show you the usability of the predefined template, what's already in there, what you can use there. Of course, we can't show everything, but I think we really give you a wide range about the possibilities. And so on that point, I think I can switch the next time to Alex with the first step for setting up the movement command, where we want to give you a basic idea about the template structure, the interaction with the motor, and also about the knowledge base. So from this point, we will switch again and go to the next demo step.
Thanks, Markus. So our first step is to implement the movement after a positive edge on input 1. Just for you, in our manual, we have also these 4 steps described here in English, sorry, to write the first motion code step by step and see the most functionalities we have. We have a powerful template here, which includes already a running state machine. So if we see here, we have a main function. This is like in every C program, the main code, which is executed by the motor firmware. And there we run a boot routine, which sets up the motor after boot up. We can change it also here. And we have a state function and state control. This is our state machine we have. The state control always defines the next state depending on the actual command. And the state function is the really executed state function. Just to be complete, the state function is here defined as a type of state machine. It's just a pointer on a function. So that we write on this function, we write the address of the function which we want to execute. So we set in the state control, we get a command. We have a motion parameter myCommand. We will come up to the motion parameters later. And in the first step, this reads in already debounced the value of the digital inputs into this myCommand. And then if no error is existing and the command did change, this switch case is entered, and here it set up, it says which is the next state depending on my command. So if my command has the value C stop, then we get into state stop. And if it has the command start moving, then it's going to the state start moving. This is just predefined from us to show how it works and for an easy start, and also used for our 4 steps. So let's see what this command stop and command start moving does. We have here a separate file, motion parameter.h, and there we defined names for my command. We use names instead of the values to make the motion code C file better readable, so that it's easy to read. So command stop is the same like in 0, and 0 means all inputs of the motor are disabled. And the command start moving is defined as a 1, and a 1 means that input 0 should be true and all other inputs should be false. So as you see in the template, the inputs get already read into my command, and depending on the input 0, it's executed command stop and command start moving, which then enters state stop or state start moving. Now we want to implement the states. So if we have a look into here, the state stop, it set up in the first time a debug variable, which says in which state we are. But then it's not really doing something like a stop command. And therefore we would have to implement this line. what it does is it writes the value 3 on the motor parameter device command. And if you have a look into our knowledge base where all parameters are described and also some samples are included, we look here into device commands, we see the 3 is the command halt, which means the motor will stop if you execute it. In the state start moving, we have to start some movement. Therefore, a function is predefined also to show our template. We see this function. It's implemented in the header file program specific functions. And here we see it's an example function for relative positioning on the given target position and the given target velocity. And it just does the movement on the motor parameters like we describe it in the sample in the knowledge base. So we say here in this line, do a movement on position 512 with the velocity 2000. Now this is already done what we wanted to do. I can compile it here or build it. I have to close the upgrader to build it. It didn't work now because the upgrader was opened. It says here error, please close the upgrader. Then I have to implement, I have to change something to be able to build again. Now it works. We see that it works when it's running these scripts I described before. And when this window opens where I have to check with enter, then we know it worked correctly. Now we see here in the folder, the MotionCode upgrader binary is from now, so it's really the new one. Now I can open the upgrader. And when it's connected and load fully, I can start the download of the MotionCode. Because this takes some time, I will give the ball to Markus to talk about the next step. And if you have questions about the first step, you could ask now in the chat. Maybe we have some time until the download is completed.
Yeah, before I share, Alex, can you at least now switch back to the knowledge base one time?
Of course.
There, just to give you an idea how the link is and how easy it works. You see at the header of this entry, you see the name of the command that you can use in clear names in the programming. You see also the data type, if you can read, write, or just one of both with these parameters. And also below, then you see the values you can move in these parameters and also what they are doing, what's the background of this value. And you see it's quite easy to start to understand which command can I use in the program. And also Alex will later on showing how easy it is to take one command out of the knowledge base and implement it in the code. So then I will take over for a short presentation again, and will introduce you the second step of the demo. In this second step, we will extend the state machine we have shown you, out of the reason why with the first implementation, we just do the positioning once and then it's done, and we don't do a second positioning by a second edge. And of course, we have to extend the program in that way that also the full functionality is there, and that we will do by a separate state and by extending the state machine. And so you will see in this next demo how to add functions and states to the program. And yeah, with this short interruption of me, we already jump back to Alex.
Thank you, Markus. You already gave a small preview. the download was successful. I will change here to English. The upgrade was successful. We can see here in the status, we have here the MotionCode status. It's executed. We can also stop the MotionCode here and run it again. And because the upgrade was successful and we see here it's executed, we know the code we did program right now is running now. We can also see here the status of the IOs of the motor. If I change the analog input, you see it here. So it's the actual values. Also the position and the velocity and so on are actual values. If I now switch on the digital input 1, you see it here. And I made a mistake. I did forget something in the state. You see here, if I if I did enable the input, the motor started moving, but it did not move to the position 512. It did move endless. This is because the state function is called cyclic, and as long as we enter this state, start moving, it's starting the positioning always again and again and again, and this is like an endless movement. So we have to add here a command to enter this state only once, and therefore we have to override the state function. And we did predefine a state named knob for no operation. And to write the address of it, we need this AND operator before it. So with this command, we say do only call this state once. Now it should work, but also what Markus already did say is if I now enable the input again, we see that the motor is not moving now. And this is because I didn't read the description of the halt command completely, because it says, please note command continue. And this says after every halt command or quick stop command, we have to do a command continue, or we have to disable the power stage between the halt and a new movement. This is why we will extend the state machine now to show you how a normal state machine works. We will extend it to do a power stage disable after the motor did stop. I will not download this change now. I hope you did understand it. I will show you later that it works then, that it's then only positioning on 512. So what we need, we want to extend the state stop, that it's doing power stage disable when the movement, when the brake phase is done, when it's not moving. So we have to add a new state. I call it wait for stop. And I will implement it here below the state stop. And what I said before, I always set this debug variable before in the first step. So when the program is not doing what I mention what it should do, I can read this variable to see in which state is the problem. You see now the value state wait for stop is not defined. I have to edit in the enum in motion parameter.h. We have here the other states predefined, like state stub. And now I add the state wait for stub, and I will take the value 21 for it. Save it, then this error is away. And what we will do in this state, first we have to find out if the motor is still moving. Therefore, we will use the status register of the motor. It's the parameter status register of the type unsigned int 32. And we see here we have the bit 3 stat moving, and this is true when the moving is active. So we have to check that it's not true. So first we have to read the parameter. Therefore, I add a local variable in an unsigned int 32 variable. And to read the value of the status register or any other motor parameter, we have the drive function. And if I add here this like an error, I can here choose the read unsigned int 32 function. And here I have to write the parameter which I want to read out. It's device status register. I can copy it from the knowledge base. Or if I know the name or the beginning of the name, I can write it and add control and space to get all parameters with this name and get something like a drop-down menu and choose it here. And then I have to say to which address the value should be written, and it's the address of my local variable I did add here. So this is read status register into the address of this variable. Now we have to check if the moving bit is active. So we add an if condition here, and we check if the status register 3 of the status register is not 3, but because this is not really easy to read later, we have predefined all status bits. You can copy it from the knowledge base, stat moving. These are all predefined in our template. So if the bit stat moving of the status register is 0 or is not stat moving, you can write it however you want. Then we will enter this if condition. And in this if condition, we will have to disable the power stage. The power stage is also an own parameter of our motor. We see it here, device enable power stage, and it's an unsigned int 8 value. So we have to use the drive function again. And now we use a write function and write unsigned int 8 function. And then like before, first the parameter name, and this time the value we want to write, it's a 0 or disable. And add here some comment, if not moving, disable. What else? I mean, it would be would make sense when the status stopped is set, not as long, just set when the motor really is not moving. So we can move it here. And to enter this state after the state stop, we have to set the state function here. Like this. So this say go to state, wait for stop. So now with the command stop, we enter the function state stop, which is here. It does the stop command and then enters the state wait for stop. And in the state wait for stop, we read the status register. And as long it's moving, we do nothing. And when it's no more movement, then we disable the power stage, set the status stopped, and that this state is not called again. We go here to state function state knob again. So that this state is only called as long as we are really waiting for the stop of the motor. I think that's it. I hope I didn't forget anything of this step. We added our new state, we implemented it, and we also did some bug fix here. And now I will build it. I have to close the upgrader first. Now I will build it. And after that, I will download it to the motor, and then we will test it together. But as long as we are waiting for the download, I would say Markus could take the word.
Yes, thanks, Alex. So then I take over for the meantime. So what have we seen now? So in this step, we have seen how to program in the IDE, how we can interact with the motor, with our drive interface. We also have seen the link between knowledge base, how to look for parameters inside there, also how to look for the parameters out of the programming with the auto fulfillment function. So I think, or I hope, it was viewable how easy it is to control the motor, how interact with the parameters, get your information out of the knowledge base and transfer it into a program. So that is what we have seen now. So I think after the download is done, we also will demonstrate you how it works this time, that we do the positioning step by step, and of each positive edge we will do one movement. And after that, after the demo of the actual function, we already jump in the third step, which means, of course, the code now is programmed. We have seen how to program it, but now it will be interesting. How can I interact with this motion code? How does the interface look like? How can I use it? And therefore, we want to show you how we can make it accessible from outside, how we can our interaction between Drive Assistant 5 and MotionCode looks alike, and also how you can imagine how bus systems work together with the MotionCode, which gives you then all the tools that are needed for you to use MotionCode. And I think based on this short part again from my side, I will hand over to Alex again.
As you see here, the upgrade was successful again. I will change to English again. And you see here the input was enabled before while upgrading, and it already did the positioning on 512, so now it's working correctly. And you see here now the digital input 0 is false and the power stage is disabled. We can check it again. I will enable the input. We see it's positioning. It's a relative movement of 512 increments again up to 1024. And we see now it's enabled as long as the input is true. And now I will disable the input as you see here. And we can see here now it's disabled like we did program it. So this works fine now. And as Markus said, in the next step, we will show you how to interact with the MotionCode from the outside, maybe with Drive Assistant 5 or also with Profinet, EtherCAT or CANopen. And therefore, we want to add some parameters to be able to change the target position and target velocity here from the outside. You see here we have motion parameters. They are defined in motionParameter.h, and motion parameters are connected to motor parameters, which we can access from the outside. So we have to add first two motion parameters now with the int32 target position and velocity, target velocity. And we should add here the comment which parameter we want to connect to it. If you open the manual, then we have a chapter where all available parameters are described. Let's see if I find it here. In this table, all available motor parameters are described, which we can connect to motion parameters. We have always MotionCode parameter, then the data type, and then a number. int32 we have 50 times, and all others we have 10 times. And now if we look here, we have an int32, and we already have some int32s predefined in the template, but they all use values about 40, so we can start with the one here. I will copy this one. I will take the MotionCode parameter int32 number 1 with read and write access, and the second one I will take number 2. How we did implement the motion parameters, but we have to tell the firmware which motor parameter now is connected to the motion parameter, and this is done in MotionParameter.c. Here we have the opportunity to set the default values. As you see here in the .h file, we have storable motion parameters and not storable motion parameters. We will talk about the storable ones later. So here we can define the default values, which will be set by the MotionCode at debug to write on the motion parameter. We can access it like this. Then I type in here target position and set it to 512 like we did before in the code. And the second one, target velocity, we will set 2000. And then we have two parts here down below. One's MotionCode or get parameters. There we tell the motor firmware which motion parameters should be readable. And in the set parameter section, we can tell the firmware which should be writable. So we have to edit here two to make it readable from outside. Therefore, I copy one of the other ones. It's a switch case statement. And I take the value 1 and assign it to target position. And I will take the number 2 and assign it to target velocity. We could add the comments too. And what now is a good point, if I hover the mouse over the motion parameter, I see here in the yellow box my comment which I did write in motion parameter in the header file, motion parameter.h. And if I'm now in the source code and I want to know which motor parameter is connected to this motion parameter, it makes easy for me to find the right one while debugging or whenever. And also I can check here that I did choose the right one above to connect it. Now the both motion parameters are readable. In the second step, I have to do them writable too. Therefore, I extend this switch case and copy also one. But I have to be careful here. I did copy a storable one. So I take the parameter 1 and assign it to the target position. And second one, I will assign to the target velocity. Now the parameters are fully implemented. I just have to change the MotionCode C file that at this point the values of these motion parameters are given to the function which does the movement. So I just write here motion parameter, target position, and the target velocity. So now every time we enter the state, the values of these motion parameters are written to the function and the movement is depending on our motion parameters. I will build it and download it to the motor because you already know now this will take some time. I will give the word to Markus. If you have some questions at this point, you could write them into the chat. Maybe we have some time now. Meanwhile, we are downloading to answer them.
Yeah, so thanks, Alex, for this third step of the demo. I think now we have seen how the interface is, how the interface looks like, how it is defined, how we can interact from outside with the MotionCode. So, or to be honest, we haven't seen it how it works. We just have defined it. So after the download, Alex will also show out of the Drive Assistant how to change parameters there and how they interact with the MotionCode to give you an idea there as well. So then I want to give you a short preview what then comes in the last step of the demonstration. There we also will add some storable motion parameters. I think that's important because you don't want to lose all the values during a power down. So therefore we have integrated the possibility to make parameters storable and keep their values over the power down. We will do this over this cycle counter, which counts every positioning cycle, and every 10th cycle we will store this. And as a short side cut, we also want to introduce the Drive Assistant 5 oscilloscope functionality to show you that how the storable parameters works, and also to show you this nice gimmick of Drive Assistant 5 that helps you to diagnose the motors. And as Alex mentioned, also we will take the chance now to answer some questions if there is one or another question. So feel free to open your microphone and ask your question if you want to, or place them to the chat. And if there are no questions available, I will hand over again to Alex to show you what we programmed in the last step, and also showing the last one.
So we see here again in the upgrader, it was successful again. This time I will close the upgrader and open Drive Assistant 5. What we will do now is the Drive Assistant 5 is able to speak with all our MotionCode, with all our MCP motors, which are able to run MotionCode. And it's not depending on which bus system you use, is it CAN open or EtherCAT or whatever. On CAN open, this Drive Assistant really can open with the motor. So we can, what we are doing now, you can also do via CAN open by your SPS or whatever. To be able to write on the parameters, we use the parameterization function. I will change the language to English. Parameterization function of the Drive Assistant. And if we go to our My MotionCode folder in our workspace, we see it already did create here some XML file for the Drive Assistant 5 with all predefined parameters of the MotionCode template. We can import it here, but because I did do this before, I already have here some XML file like it. I did add the two parameters here already, but to show you how it works, you can here go on the plus and then type in the parameter name. We had int 32 underline 1 for the target position. And as you see here, on this CAN address, you can access it via CAN bus, or on this parameter name if you have a Profinet motor or EtherCAT motor via EtherCAT. If we enter it here, we already see the defined default value did work. We already have it up here. I can add here a comment to say it's the target position to make it easier to use later. Now, if I enable the input here, as you see, I'm running to position 512. And if I change the value now to, like here, 50,000 and the velocity to 3,000, then we will see that I'm moving to the position 50,000, 5012, because we added 50,000 to the old actual position. So the parameters to work, I can read them, I can write them, and we can also add them into the cyclic data of our bus system we are using. In the last step, now we did work with not storable motion parameters. In the last step, we want to add a storable motion parameter to implement something like an cycle counter. So we have to choose the data type. I will take an unsigned int 32 and call it cycle counter. And I will I will combine the parameter unsigned int 32 number 4 to it. It's then read, write, and store access. And really important here, storable parameters have to be implemented as a pointer because they get a fixed address so we can store them later. Now I have to implement the read and write section here, and the default value up here in motion parameter.c. And what's the difference because storable and not storable parameters is that I have to assign a memory file in the MotionCode init function in MotionCode.c to be able to store it later. So this is done like this. I take the motion parameter. This time I'm writing on the address of it, and therefore I use the drive function. And in the drive function, I use the memory function and define the memory field 1 to be assigned to our motion parameter. And I have also to give the data type here. So now the memory field 1 is assigned to my motion parameter cycle counter. And then we have to implement the cycle counter itself. It should always count up if I'm entering the state, if I start a movement. So I take the motion parameter and add 1 here. And every 10th time we want to save it. So we have to implement if action. And here we ask if it's the 10th time. If it's the 10th time, then we use the drive function and the store function of the drive function. And we have to say to the store function which memory field we want to store. Because we only want to store the cycle counter and not all parameters we have. And we have it's an array, and we have the field 1 of the array, and this is binary 2, so we have to store here with the 2 the cycle counter. This is what we have to do. I will implement the read and write access now, and meanwhile Markus will take the word and tell you something.
Exactly. I think we also recognize that we are running out of time. So I hope you still have 5 minutes more than scheduled for this webinar. I will give you a short overview where the way goes for the future with MotionCode and how is there further possibilities. In the meanwhile, Alex will do the final programming work and then we can show you the result. So and where the road goes with the MotionCode programming. So I've already mentioned it. There are some points in the pipeline where the way goes to. I will say with a question mark, because we say, can it be graphical programming, or is it will it be built out to a full engineering suite where you can move hardware on the hardware tree, assign different code functionalities to the hardware? Is it a debugging function or pre-programmed function libraries you directly can use inside the code, or also parallel executable motion codes? So I think that's our ideas where the road can go. What can be further implementations of MotionCode or add-ons, or something completely different. So what I just want to mention is the actual package is available, it is working, it is running, and we are rolling it out in the moment. But what comes next is really up to you. So use the chance and jump up on the train and start using MotionCode, because then you also have the chance to give your input for the further direction, which functionalities are needed most, what should be integrated first, and yeah, you have the chance to design the way where MotionCode goes to. As well, MotionCode has a close link to our industrial IoT developments, which extend the functionality of just the field level where the control is done, to the edge level where supervision, data aggregation, and monitoring can be done, up to the cloud level for managing and whole fleets, managing motion codes. And I think that's the link. If you have motion codes running outside on the motor, you can manage them via IoT remotely, update them, upgrade them, and interact with them. So you have a consistency from the field to the cloud level, and therefore, so we can offer a one-stop solution from controlling up to monitoring what's really happening. And what is really important here to explain is the openness that we have with our solution. I think you see it with Eclipse, you see it with our interfaces. We always set on open solutions, and that we also do in this direction, that we set in Docker containers. We also use OPC UA, MQTT. There are no proprietary ways. We always set on open technologies. That's also the reason why we are an active and proud member of the Open Industry 4.0 Alliance to support an open and common accepted IoT and motion code environment. And from this point, I just can say MotionCode is ready. It's an easy tool. So just start with programming. And as a short side note, remember the October 11th, there we will have a bigger announcement around MotionCode IoT, where the way goes to. And from this point, of course, later on, place your questions, contact us also after the webinar, send us your questions, and now feel free to join the last demo from Alex, where we show how the last implementation has to be, or how the last implementation works.
Thanks, Markus. So we see here the upgrader was successful again. I can change to English. It was successful. In the next step, I will change to Drive Assistant 5 to show you that our cycle counter is working and that it's stored correctly. Therefore, I can use the parameterization table like before. So we had here our parameterization. I already added the parameter here, unsigned int number 4, but it's also a very good function, our oscilloscope. There I can add the digital inputs. and also this unsigned int 32 number 4 parameter. And if I start a record now, we get like an oscilloscope, the live data. If I enable now the input, we see here the edges of the input, and we see in yellow that the counter is counting up. And if I do it more than 10 times, now we have a 14. Now I switch off the electronic supply shortly to show that it's stored. And if I enable it again, we see it was going back to 10 because we did store at the value of 10. And now it is still working. So everything did work. We did complete the 4 steps. As Marco said, if you still have questions, feel free to ask us. And I hope it was interesting for you. Thanks for joining.
Yes, thanks to all for joining this webinars, and feel free to use the chance now and place some questions or contact us later on. We would be happy to hear from you and answer your questions. And thanks for your time and also your overtime of this late webinar.